Hello, welcome back to Plumbing College. Today, Brian, the electrician, is going to show us plumbers what electrical tools and testing equipment we need when we're just starting out getting involved in electrics.
This is a basic electrical connecting kit for a plumber to do basic electrical work, but we must stress the minimum qualification for doing electrical work is a Part P. Over this side, we've got some test equipment. Some is authorized, some is not authorized. This is electrician's knife, and you can see the blades on this side. This doesn't need to be that sharp. You can test it by running your thumb across. Do not run it backwards and forwards. So we use the knife to run down the side of the CPC. If you hold it about here, you will cut yourself. So hold it very close, and you run the knife down, and you'll feel it running down the side of the CPC. So you need a slight angle on the knife. That's all you need. Then you can pull back the outer insulation and you can cut this off. You can see this is a quality cable because this has French chalk inside it. There are some cables that do not use French chalk. And you can see the residue of chalk on there, and we can check there's no damage to the cable. Right, this particular cable is known as FP200, and it's not difficult to strip. It's very easy to remove it, and you can bend it accordingly to get nice bends and straighten up this. All fingers and thumbs. To strip this cable, we would use a knife. So we've used the knife in the standard way, blade one side, thumb the other. Run the knife round. And what you do, you will just, it will pull back on your mark you made. And you just pull off. You can use electrician's knife to strip the cable, but it needs a bit of experience. The same method, thumb one side, the other, run the knife round, see where it was, and you can see that it will come off. There's various types of side cutters. This particular type, if you look carefully, has got two small holes. These are the common sizes of conductors we strip in electrical, 2.5 and 1.5 or even 1 mil. Here is our cable, so we line that up on the small hole first, press down, use your thumb and pull. If you have a pair of wire strippers, then you need to adjust them. You have to adjust these for the size of the cable. So what you'll need to do is to adjust them for the conductors you're stripping. That's the only disadvantage. So we'll open this up a little bit on the small vernier, and we're going to do a test to see if this is correct. And what you want to do is put it back in again, and if you can feel the copper binding, you know you haven't got it quite right. Now while you hold that tight, you do this locking nut up there. Then that is set correctly for the same size conductor you want to strip. So we'll strip this one. Now we're going to use the pliers to bend the conductors over, because all single terminations must be doubled over. So we're going to adjust this to our length. Use your finger to get approximately 50%. Bend it over. And you can see it is ready for terminating. You could use this part of the pliers for stripping the cable, but it takes a little bit of skill, how much pressure to put on. But the pliers really are for bending the conductors over, so we fill up the complete terminals. There we are. This is a semi-automatic type stripper. They vary in cost. The quality ones will cost you about £80. This one's probably about no more than £30. And how this one works is you would put the cable in like that, you would press down, and you can see it pulls the outer insulation off. So you have to remove this yourself. Now to strip the conductors, it's the same process. Put it back in again, and you can see it strips the conductors. This cable is a 2.5 20 Again, we can use this semi-automatic stripper. You put the cable in there and you press down, and you can see it strips the outer sleeving off. Then you'd have to pull this off. Again, you can put it back in to strip the conductors to the required length you require. And you take those off, strips. You may be wondering what these bits are for here. This is for putting crimp terminations on, but there is a disadvantage with this type because it relies on the person of the maximum strength they can put. These are the crimps, and they come in different colours. Red indicates 1.5, blue is 2.5, and yellow is 6 mil. Once we get above 6 mil, then there's no colours. The actual number is printed on the crimp. So we strip our cable to the appropriate length. If it's the appropriate length, the copper should come just outside where the blue insulation is. So on this particular device, we've got various areas where we can do crimping of conductors onto crimps. Here it's marked yellow, red and blue. This is a blue crimp. So we're going to put this in, line the crimper up with these areas and press down. With these you may need two hands because you've got to put all the pressure to get these correct. If it's crimped correctly, it shouldn't pull off. So this is a small hammer we could use for clipping. If you're using this hammer a lot, you'll want to check it's balanced. And how you check it's balanced is by putting your finger underneath there and to see if the weight of the handle equals the weight of the head. If you've got these two hammers, the claw hammer is a heavier hammer. So if you've got a lot of clipping, your arm will ache with this one. With this one, it won't. Electricians normally use insulated screwdrivers, either a posi number 2 or a number 1, a small terminal screwdriver, and a slightly larger bladed screwdriver. Plumbers may use this type of screwdriver with no insulation on, because it's possible at times electricians do work live. That's why we use insulated tools. We have a range of basic electrical test equipment to ensure if the circuit is energized or de-energized. This one is totally illegal to use. This is the approved voltage indicator with the proving unit. These ones do a very good job, but they're classed as non-approved. These two do a very similar job, but this one's got an advantage because it has a buzzer on it. We plug this into a circuit, we want to see what state of play it is, and you can see 2 green lights comes up telling us it's live and it's correctly wired. We can go through the colour sequence on here of the lights, which tells you if there's a problem with the supply. The second one we're going to use is similar. You plug this in and it has that low pitched sound. So if you have to go to a distribution board or a consumer unit, you can hear this at a great distance due to it being a very low frequency. It's a voltage indicator stick, but unfortunately these can be misleading. So we go over to our socket and we turn this socket on and we get into our live conductor, and you can see it's making a sound, it's lighting up. It shouldn't light up on the neutral or the earth or the CPC. If we turn this off, it shouldn't light up. Another use for this would be is to check an extension lead is live. As soon as you've got this turned on and hold it near your cable, you can see it starts livening up. This was known as a neon screwdriver, which a lot of people used to use probably 30 to 40 years ago, but now they're deemed to be illegal to use because they are so misleading. And for us to get an indication on here, turn on, touch your finger on the end, and you can see the little orangey glow light that's lit up. If I touch that, you can see the distance of the light is increasing. So that means there's a small current passing through my body. This is the GS38 approved voltage indicator, and it's approved because there's no switchable range on it. This is the proving unit. The length of the tips must be between 2 and 4 millimeters, ideal 3 millimeters. So we're going to check our piece of equipment is working, and you can see it's working and the voltage is correct. This indicates it's live by the sound and the voltage indication on there. So when you take this off, it's live first, then earth. Another use for this approved voltage indicator, this particular one has got two functions. It can measure voltage and continuity. So if we have a small lamp and you want to check its functioning, and you can see if I hold that on, we have some continuity of the lamp. So it's disconnected from the supply, and we can go across there and you can see that we have continuity of the fuse, so we know the fuse is perfectly okay. A plumber wouldn't use today because these are sufficient, because this one will check continuity. So if you wanted to check the resistance of a thermostat, it's actually working, you can do it.
Now you know what electrical tools you need. It's your turn to use them.